See, Bob's got a new look there. I like it.
Joan, it's all yours.
Okay. Well, good morning, everyone. Good afternoon. Happy lunchtime, depending on where you are. Welcome to our session on using process data for advancing the practice and science of educational measurement. Really glad to have so many people here. Hope you're all doing well and staying safe and sane during these challenging times. And really glad to have you. I think you're in for a real treat this morning or this afternoon. 3 really interesting papers about adding new dimensions to our measurements: the assessment of response processes, the advent of technology, and the oceans of response data it provides potentially opens lots of new windows into student thinking and the inferences we can glean from testing and student responses. We'll start this morning with Bob Misleby, who is presenting a paper and adding to a paper written by Roy Levy, who lays out a modern vision for psychometrics and discusses how that vision can inform the use of process data in educational measurement. Kadria Ursikan and Randy Bennett, each representing a team of colleagues, will then follow, each presenting their research on the use of process data. They each present different kinds of measures for different purposes. Jim Pellegrino and I will then offer some commentary on the paper, and we'll leave lots of time for you in the Zoom universe to add your thoughts and questions. Each of the presenters will take about 14 minutes, give or take 10 or 20 seconds to share their papers with you. The chat room is open for everyone's comments and questions and thoughts. And just a reminder that this session is being recorded, so don't say anything that you don't want the world to hear. Before I turn it over to Bob, I just want to mention also that the 3 papers will appear in the next issue of Educational Assessment, and those papers also are in the process of going online. So with that, I'm going to stop my share and turn things over to Bob. Take it away, Bob.
Okay, sharing screen. And starting up PowerPoint. And let's see, where is the slideshow? Go. Okay. Can anybody see this? Uh-oh. Can anybody
yet.
hear me? Okay.
We can hear you, but we don't see your screen.
Oh, you don't see my screen. I wonder why that would be. Let me try.
Hit share screen.
Yeah, I'm trying to.
It's the green button at the bottom.
Do you have multiple screens working, Bob? You may have to move the screen.
Okay.
There we go.
Oh, okay,
Okay.
good. All right, good. All right, let's start again. And I'm not going to count this as part of my 14 minutes either. It's not my It's Bill Gates' fault, I think. Okay, and start from the beginning. All right, here we go. I will not take a lot of time to get into this, but I just want to say that this is something that Roy had all in a draft and was ready to come, but apologized he couldn't make it today. He asked me to fill in, and it turned out I gave a talk about 1.5 years ago that had almost the same title, and we looked at it and it overlapped about 75%. So here it goes. There are two organizing frameworks in the talk. One is an idea that we picked up from John Behrens, who in turn picked it up from John Chambers, writing about when he wrote about lesser and greater statistics. What John Behrens meant for greater and lesser psychometrics is this. For lesser psychometrics, it's focusing on the models, the measurement models, ways of estimating, way of structuring models, all of the things that are sort of inside the model space, and look outwards to how it connect, but just look at them and wait for connection to come in. By greater...
No. I want to close it.
Pardon? Is someone asking me a question or talking to me? Okay, I'll keep going. By greater psychometrics is looking at the entire process of what it is that you're trying to do, the entire chain of reasoning, of which psychometrics might be an integral part, but it is far from being the whole. And in fact, without understanding, and in fact, in more complicated arenas, designing in part together doesn't really make sense. You might be able to build great tasks, have an idea of a construct that's very innovative, and do all of that work without ever thinking about how you're going to analyze it when you get done. You can't really count on fancy psychometrics to save you in that case. So the second organizing framework is evidence-centered design. We're going to use this as a structure to help connect how the psychometrics integrates with the development, the use of all of the capabilities, the design, the evidence identification, the activity spaces, all the technological advances, how those things integrate from beginning to end with the psychometrics. So in terms of ECD models for instantiating assessment arguments, on one side, you have constructs. What are the things that you want to assess, get some characterizations of for some purpose? On the other side, we see people doing things, test takers, doing things in some kinds of situations that we think are going to give us evidence about what it is we want to assess. Traditionally called tasks. I used the term activity space a little while ago because that's much more general. It includes test items. It includes multiple choice test items. as special cases. But you've got those on either end, and what you have in the middle is, well, what are performances in those situations tell you about the capabilities that you want to assess? And that's where the argumentation and the psychometrics in analytics come into play. So what we have here, what you want to assess, the models, the machinery is variables and a student model. Over on the other side, we have task model, activity model. And on the furthest right, what we have is characteristics of the activity space, what people see, what they can do, what they hear, and so on. And some of what they do or make, you capture in what we'll call a work product. And there might be a lot more going on in the activity space, but there's a certain part of it that you're going to capture. And in the middle, we have two pieces. One is, all right, from the stuff you've captured, what's important? How do you characterize nuggets of evidence? This is a very simple picture here. And in fact, in more complex assessments, you might have multiple layers and many types of identifying evidence procedures. You know, a couple actions have a meaning. A pattern of meanings might suggest tactics. Patterns of tactics might suggest strategies or switching strategies. Combining those things as evidence about the things you care about for students in terms of student model variables. This is what is usually thought of as the psychometric part. Much of it is, although some of it is in evidence identification. And a lot of what you read in psychometrics books just only looks at this box here. You've got X's coming from somewhere, you have thetas that somebody else thought of, and your job is focused on those connections there. How, when you see the X's, what does that tell you about the thetas? All right, so to talk about this quick in a familiar multiple choice kind of test, overall proficiency, that theta is unidimensional, how well you do on a bunch of multiple choice items. And this is what the activity space is. You're in there, you're answering questions. Not all that gets captured. Traditionally, we just get a vector of what are your selected options. There's a lot of other stuff going on there. Timing, breathing rate, erasures and reconfigurations, all that stuff. Kadria, I know we'll talk more about that. Also going from that work product down to a nugget of evidence, well, is it the right answer or not? And then the evidence accumulation, the making sense across those nuggets of evidence as evidence for what they tell you about the thetas, simplest case, classical test theory or IRT. Now, when we start to think of new forms of assessment, all these things can become richer, provide more evidence, but more challenging to do. The picture I have here, I'll use the same one for convenience, but bear in mind that these things can play out over time too. And the action and the inference, all of these elements can be evolving and changing over time. So coming from the term of constructs, what we see in more complex assessments, possibly multivariate student model variables. They might be required in different mixes and different situations in the activity space. They might change during assessment. For example, if you're in a learning platform, you really kind of want them to change. You would like people to learn things. Or there could be strategy shifts in a complicated problem where someone has to try multiple times or see how one thing works, and if it doesn't, try something completely different. And often the constructs that we have in mind, like communication or like troubleshooting, are not well evidenced by encapsulated non-interactive performances. So all these things in terms of constructs are making us think about more activity spaces that have interaction and so on, that can lead to more complicated performances and therefore more challenges in evidence identification. Some of the ones that, that I know about are collaborative and cognitive skills, where you have multiple people solving physics problems together, interactional speaking, troubleshooting, which I've mentioned before, computer networks is one that I've worked on, and geometry, one that Roy brought. The Insight learning system for kids is based on a learning progression for understanding. So you can see already that is going to be driving the design. So we come to the activity spaces or tasks. Well, those two, as I mentioned, can be continuous. Sometimes there are no such thing as discrete tasks and responses at all. The computer network troubleshooting platform, packet tracer, you kind of sit down at a terminal and it looks very much like it does when you're solving a real problem. There are many devices out there you can communicate, that communicate each other, and you have a space to explore, to revise, to fix things. So in general, you can have interactive tasks. That's a really important thing. A lot of capabilities that we're interested in involve inherently interaction. So we want to the extent we can, have interaction in the activity space. And those can be actions among things, with systems, with other people, with avatars. This one is from the Insight example that I talked about a minute ago. I use this one because it's the simplest one and the cutest one. This is a task that is designed in accordance with the learning progression that the construct is built on. And here the kids are going to have to tell you how many squares are there for the hippopotamus yard, but they need to show you how they do it on this little calculator to the right. We'll come back to that. For work products, as I mentioned, there can be a lot of things going on in the activity space, but you don't capture all. So you can even have familiar task types, even the multiple choice ones we mentioned before, but now capture much richer kinds of data, timing, actions, sequences, revisions. There can be a lot of evidence about the construct there. There can be a lot of evidence also about the quality of the evidence and cues about how you might improve the assessment going forward. You can also then have logs of actions and utterances. You can have video capture, can be multimodal, physical, such as gaze, heart rate, breathing, proximity. All of these things now we could, in principle, have captured as work products, as sources of evidence, but we look back to the construct to think about what might potentially be useful. Why do we need it? How does it fit in with the argument from what you see people do to what clues it gives you about what they can do, how they're thinking about it, what they might benefit from learning. Now, evidence identification. Roy thinks that this is probably the most important part here. A lot of psychometrics developed with good reason to best understand and use the evidence in pretty simple kinds of work products, nuggets of evidence. Now we think about, we have a work product, it's complex. What is it that we want evidence about? So the nature of the construct, how people act with different configurations or different levels of knowledge, that ultimately is the kind of evidence we want to capture. So for example, we might identify classes of collaborative moves from examining interactions in a conversation, even though every conversation is different. If you're going to do this in an automated way, which we often do, well, it's kind of interesting because there were complex performance tasks in the past, but raters would evaluate them. So a lot of the complicated things that they did in their heads, we now kind of have to figure out what it is they were looking at and why, and how to start make that explicit and to see if we can even do better. So we can look at fine-grained, real-time evidence identification to understand these interactions in the adapted situation. We can pull in all kinds of knowledge that we have to help us do that. Conversation, whoa, boy, that was fast. Okay, I will talk even faster. Multiple stages of evidence identification. You may have layers, in fact, of psychometrics. Here's what the evidence looks like in the happy hippo in their yard. And you're going to see in a minute that those different kinds of patterns give you clues about how a kid is thinking about solving that problem that just a correct answer doesn't. I mentioned briefly, a lot of exciting things are happening in the lesser psychometric space that are necessary, they're innovative, but they're not sufficient. Examples, general latent variable modeling. For dynamic learning situations, we have hidden Markov, dynamic Bayes nets modeling. Another thing that I've worked on a bit that I find fascinating is this dialectic between design and discovery. We can have a complicated workspace. We've built it so that we know certain things are important as evidence, but we can use those to bootstrap with data mining techniques to find patterns we hadn't discovered, that we hadn't known about to build in. And also, you can extend ECD with learning models. So the transitions between states in the student model, what you need to look for that signals states and levels, what you build into task and activity space to help promote that learning. And then finally here, the happy hippo, this is how those patterns in the calculator give you evidence. This is in the pure form of how the kid is thinking. What you're really going to see isn't just these four things, but these are like attractor states and the 10,000 different kids are going to do. Some will make sense along these areas, some will not. So you have richer information, and some of it will be much better, and some of it won't make any sense at all. You have more design work cut out for you. So I mentioned a lot of things that we have to do to overcome limitations of familiar psychometric models. Actually, a lot of this work has been done in sort of like tabletop work in the area of psychometrics, but now we have not only the opportunity, but the necessity to put these into play and to extend them. The last of my slides before Roy's big send-off is that things like validity, reliability, comparability, fairness, Sam Messick told us those aren't just measurement issues, but social values, no matter what we're going to be looking at: tasks, psychometric models, evidence identification. And there are a lot of concepts and tools developed in ed measurement with the simpler kinds of paradigm that we need to reinterpret, extend, augment, create anew as are needed for these extended arguments, not just extended data. Okay, let me hit here and see if we can have Roy's conclusion.
Hi everyone, it's Roy. I'm sorry I couldn't be there synchronously for this session. I did want to leave you with some takeaway points and messages from this work on the distinction between lesser and greater psychometrics and the push towards greater psychometrics. I really see this framework and distinction as organizing or helping me think through a lot of the ideas and themes that I've adopted from other work that I've come across or conducted. One is about evidence-centered design overall. Evidence-centered design pushes us to think jointly about aspects of design, data analysis and statistical modeling, and interpretation and claims we'd like to make. It pushes against the notion that there's an assessment design team on one hand who does their work, and then when they're done, they throw the data over the wall to the lesser psychometricians who work on things like statistical modeling and evidence accumulation. And the idea that things have to be done jointly or that we benefit when they're done jointly is captured by the saying that an ounce of design is worth a pound of data analysis. And while historically it may have been the case that the quality and scope of our inferences were limited to the capabilities of the statistical models, I no longer think that's really in play. That is, the statistical modeling is not the limiting factor on the type and quality of inferences we make in assessment. The statistical modeling is not the hard part. The hard part is knowing what goes into those models, making those choices, understanding what it's going to give us. And the last substantive point I want to make is really a confession, which is that I'm a lesser psychometrician. Now, I'm sure I've been called that many times in the past, meaning one thing, but I'm using it in the current context right now to refer to the fact that I got into this field because I was interested in statistical models and how they could be used to analyze data. And I still find work on statistical modeling and evidence accumulation to be interesting and rewarding. But this is really a comment towards other lesser psychometricians like me, which is that if we ignore the other aspects of greater psychometrics, we do so at our own peril and to the detriment of the field. None of this really depends on process data. All of what I've just been saying, I think, holds regardless of whether we're looking at process data. But process data forces us, I think, to better appreciate the value of taking a view of greater psychometrics as opposed to lesser psychometrics. Finally, I want to thank Bob for stepping in to participate in this session in my absence. You may have heard that this was a last-minute change to the program. Actually, I've been planning this all along. This is my idea from the get-go. This is my performance art piece to illustrate and embody the value of replacing a lesser psychometrician with a greater one. Thanks, Bob. Hi, everyone. It's Roy. I'm sorry.
Okay, well, I thought that was a funny joke, but it is just a joke. I think that I am done. My last comment is I really appreciate the opportunity to have joined with Roy and to share the ideas that we have about process data. Thanks.
Okay. Thanks, Bob. If you can stop sharing, I will.
Yes, I found a button for it. There we go.
Okay, great, great. Hi, everyone. I'm Kadriya Erçakan from Educational Testing Service. I will attempt to share my screen. And I'm having difficulty as well. Well, I will try one more time.
Do you see the screen share, the share screen button at the bottom?
Yeah, I'm pressing that and I'm seeing my screen and the options on my screen. And I press on the PowerPoint.
I think once you select the PowerPoint in the lower right, there should be a share.
Okay, perfect. Does everyone see this? Yeah, great.
Yes,
Okay, great. First of all, I want to thank NCME for these virtual presentations. I'm really grateful to be able to have a chance to present and also participate in the other virtual presentations. It's really been wonderful in this COVID time. I'm going to be talking about use of response process data to inform group comparisons and fairness research. This is, yeah?
excuse me, but you may want to take it off. You're in speaker view. You may want to put it in slideshow view so people don't see your notes.
That's what I see on my screen. I'm in presenter view.
So,
And okay, I will stop share and attempt one more time. Okay. Did this work better, or John?
you're still in, I think, presenter view, and you want to be in slideshow mode. Just change the mode that you're in PowerPoint.
Okay.
You won't be able to see your notes, but.
Okay, and what's the problem with the, okay. All right, so I will go to slideshow. So is the problem that you see my notes, or?
Yeah, we're
Yeah,
seeing,
we're seeing-
Okay, all right.
we're seeing
so-
everything you're seeing.
All right. Better? Okay. Okay.
There we go. There we go.
All right. I want to acknowledge my co-authors, Hongwen Guo and Chi Wei He. This was a true collaboration with the two of them. And just to let you know that Hongwen is monitoring the chat. So if you have any questions, feel free to post them there, and she will respond, and I'll try to respond later on. Group comparisons is critical in an important goal for educational assessment, and critical in documenting gaps in learning outcomes for comparison groups such as ethnic, race, language, gender, and cultural groups. Also important for providing empirical evidence to inform policies and practices for improving learning for these groups and closing the achievement gaps. In all of these comparisons, comparability of scores and score meaning for groups is central to comparisons and fairness research. Typically in educational assessment, comparisons focus on examinees' final answers and responses to test questions, while ignoring response processes, such as whether students from different groups engaged in assessment in similar ways. For example, in the completion rates, or completion of items, or the whole test, the speed at which they go through the assessment, and the extent to which or how they use tools provided to them by the assessment, such as language tools, graphic tools, etc. We also ignore in these comparisons whether students from different groups use similar solution strategies and numbers and sequences of actions. Differences in response processes can provide important insights and can have implications for comparability of scores. Comparing response processes is an important way to examine the degree to which relationships between actions and targeted constructs are similar. Also, how examinees engage with assessment is central to score meaning and the kinds of claims we want to make. Therefore, differences in response processes are relevant to measurement comparability, consistency of score meaning, and central to fairness. In this presentation, I'll introduce methodologies for identifying differential response processes, apply these methodologies to examining differential response times for English language learners and others in a mathematics assessment, compare these methodologies to the traditional fairness research results, traditional differential item functioning results. And finally, discuss findings and the next steps. Differential differential item functioning, differences in response patterns are typically examined using differential item functioning. Diff is defined as item score differences between groups of students matched on scores, and is commonly used as a key aspect of fairness research. There are different diff methodologies. One we will use is standardized mean difference diff, developed by Durance and Kulik, and adopt this methodology to two different differential response time statistics. One is defined as item timing differences between groups of students matched on scores. In other words, students from different groups, ELL versus non-ELL, matched on scores, to what extent they have similar testing times. The second one is a related statistic, differential response time, matched on total response time. In other words, students from ELL versus non-ELL who tend to spend similar testing time across the tests, how comparable is their testing time on a, or response time on a particular item. We apply these methodologies to data from a mathematics assessment with 15 items, score ranges between 0 and 26, and maximum testing time 30 minutes. We had large sample sizes, 25,000 for non-ELL and 3,000 for ELL. There was a performance difference between non-ELL and ELL as expected. Non-ELL mean score 9.31 and ELL mean score 5.39. The difference is statistically significant. The total median time in minutes was 22.9 for non-ELL and 23.5 for ELL. In other words, slightly longer for ELL. In examining the response time and its relationship to the comparability of scores, it's important to try to understand the relationship between time and performance and scores on the test. What you see on this graph is median score, meaning score on the y-axis and response time in seconds on the x-axis. The green dots that you see on the bottom are for non-ELL, and the red dots are for ELL students. The two lines that are close to each other are mean and median. What we see here is that there is a strong and consistent relationship between response time and performance score for non-ELL. Very consistent, going all the way up, and a strong relationship. When we look at the same relationship for ELL, we don't see as consistent a relationship with the score. In other words, the longer testing time does not necessarily mean higher performance, higher score on the test for ELL students. What we also see on this graph is that for the same score, if you focus on the vertical axis, ELL students tended to have longer time compared to the non-ELL students. Just a quick overview of the relationship we saw between response time and the performance. This is one graph summarizing diff results and the differential response time results. The top chart are diff effect sizes for the 15 items. They are all very low and below the threshold of 0.1, and so indicating that none of the items in this mathematics assessment were identified as diff. The two other bar charts are for the DRT statistic. The one in the middle is for DRT-SS, conditioning on the total score. What we see here is that they're all positive, and most of them are statistically significant, indicating that conditioning on total score, ELL students tended to spend more time compared to the non-ELL students on almost every single item. What we see in the bottom, the third bar chart, is that some of the statistics, the DRT statistic conditioning on total testing time, half of the items, the first half of the items, you see a positive statistic. And on the second half of the assessment, you see a negative statistic, DRT statistic, indicating that matched on total testing time, ELL students spent more time on the first half of the test, and then less time on the second half of the test. Overall, what we see is that diff analysis on item responses indicate that items function similarly for the ELL and non-ELL groups. And based on just the diff findings, we would conclude that there is no evidence to suggest that there are threats to score comparability across the two groups. However, based on timing data, we found differences in response times for groups matched on score level and total time, indicating differences in engagement with the test. Also, we see an example of DRT statistics providing insights about students' test engagement that go beyond what may be identified by diff analysis using response data only. What's the significance of this? Differences in response time for ELL at all performance levels highlights the potential impact of such differences on overall performance levels and therefore score comparability. For example, ELL students who need more testing time to demonstrate their knowledge skills on the assessment might be disadvantaged on speeded tests. Shorter time in the second half of the test based on the second DRT statistic is a little difficult to interpret. However, it does point to potentially ELL students having a lower test engagement, potentially due to test anxiety and frustration. Moving forward, we plan on refining the proposed methodologies, do further explorations of the implications, consequences on performance, and examine both construct irrelevant factors such as familiarity with technology and linguistic demands on some of these items for the comparing ELL and non-ELL students, and also explore using more process data features, for example, actions, sequences of actions, and number of actions. I didn't time myself. I come to the end of this presentation. Thank you. Randy, over to you.
Okay, thank you. Okay, let me know if you can see. Okay, good.
Okay.
Thanks very much. In this talk, I'm going to describe a study of how proficient and less proficient students differ in their composition processes. This is a study done with my colleagues, Mo Zhang, Paul Dean, and Peter Van Ryn at ETS. This research question is of interest because it's been studied in the cognitive writing literature, and that research base provides a theoretical grounding for examining this question in the educational testing context, in which it's been far less extensively researched. In the cognitive writing research literature, results suggest that stronger writers tend to more efficiently manage the writing process. That is, they coordinate activities like idea generation, text production, monitoring, editing, and revision much more efficiently and effectively than do weaker writers. Stronger writers tend to produce text fluently in relatively long chunks and bursts. They tend to pause at natural junctures like clause and sentence boundaries, and they tend to engage in more editing and revision. In contrast, weaker writers tend to produce text less efficiently. They tend to pause at locations that suggest difficulties in typing, spelling, word finding, and other transcription processes, so more often within words and between words than between sentences and phrases. And they tend to make fewer changes to their text. The instrument used in the current study were two scenario-based CBAL English language arts assessments, each of which focused on a different persuasive writing genre. One family of 3 test forms focused on argumentation, and a second family focused on policy recommendation, that is, choosing among options and justifying that choice. Students were expected, as part of the examination process, to read a scenario and the source materials associated with that scenario, to answer lead-in questions designed to engage them with the source materials and scenario, and then to write a culminating essay. Data were collected in 2013 from a volunteer sample of schools in 8 states. Each student took 2 of the 3 parallel forms in one or the other subgenre. The argumentation forms were given to students in 7th through 9th grades, which were the grades for which these forms were most appropriate, and the policy recommendation forms to kids in 6th through 8th grades, the grades to which these forms were targeted. For this study, we retained only those students who submitted both essay responses, which for argumentation was 631 and policy recommendation about 850. With respect to data preparation and analysis, we first fit an IRT model to the responses from all 3 forms in a subgenre, and then estimated essay scores from that IRT model to place the essay scores from the 3 forms in a subgenre on the same scale. We next merged records across prompts within each subgenre to increase the sample size. Third, we divided students into quartiles based on mean estimated IRT essay score taken across both of the essays that a student responded to. Creating these quartiles was a simple way of generating writing proficiency levels. That is much simpler than the more laborious way of setting standards, of going through a formal standards setting. Fourth, we compared writing process variables across these essay score quartiles using Mankova with form, pair, and gender as covariates. Form pair because it might matter which pair of forms one took, and gender because we know from NAEP as well as other studies that girls at this age perform more skillfully in writing than do boys. And finally, we considered a result to be noteworthy only if it occurred across both student samples, and again, those samples differ in subgenre and in grade. The dependent variables were writing process measures of 2 types. The first type consisted of 4 simple individual features. Initial start time, which was the proportion of total writing time spent waiting prior to beginning to compose, which might be indicative of the relationship between planning one's essay and actually executing it. Typing speed, essay time, that is the total time spent on the essay from beginning to end, and number of words started, which includes words that might have been deleted through editing. Essay time and number of words started can be thought of as very gross indicators of effort that might not be as visible in the final essay product. For example, a short essay might be associated with a high number of words started if a student deleted a lot of text in the process of composition. The second type of measure consisted of 4 composite process indicators, which are described in detail in the paper and which were developed in some of our previous investigations. Fluency represented efficiency in generating text and getting it onto the screen. This measure is obviously affected by typing speed, but it's also affected by verbal facility. Macro editing represented the extent of modifying mostly multiple words of text, local editing, the extent of changing mostly individual words, and interstitial pausing, the extent of waiting, primarily between bursts of text and between sentences, which is associated with planning in the cognitive research literature. Here are the Mankova results for comparing the essay score quartiles in terms of the 4 individual writing features simultaneously, that's in the top panel, and separately for the 4 composite indicators in the bottom panel. We see that essay quartile is always significant, as is gender, meaning that the quartiles differ on 1 or more process variables, and the writing of boys and girls differs on 1 or more variables too. Form pair is not significant in 3 of the 4 instances. Let's first look at the results for each individual feature. Here are the results for the first individual feature, initial start time. The observed quartile means are at the top, the adjusted means graphed on the lower left, and a table of between quartile effect sizes and statistical tests is at the lower right. Argumentation is below the diagonal, policy recommendation is above the diagonal. For both subgenres, more proficient writers used a smaller proportion of their total essay time before beginning to write than did the less proficient writers, which you'll see in a moment is because more proficient writers spend more time writing in total. This slide gives typing speed means. Again, for both subgenres, the differences between more and less proficient writers are statistically significant, with the more proficient writers being considerably faster typists. The first and fourth quartile policy recommendation means differ by something close to a full standard deviation. Although the subgenres show noticeably different typing speeds, which you can see here on the graph, it's not clear whether these differences are due to the subgenres themselves or to the differences in grade distributions between the 2 student groups. For both essay types, the more proficient students spent more time on their compositions by a very considerable amount, well over a standard deviations difference between the first and fourth quartiles. Not surprisingly, given that they spend more time writing and type faster, the more proficient students also start more words by a very large amount. Again, well over a standard deviations difference between the top and bottom quartiles. And as the graph suggests, the difference is especially big between the adjacent third and fourth quartiles. Moving on to the process indicators, more proficient writers have higher fluency scores than less proficient writers for most quartile pairs. Moreover, the differences between the highest and lowest quartiles are quite considerable. This result is consistent with the results from a number of other studies. For the second composite indicator, macro editing, we see statistically significant differences for argumentation, but not for policy recommendation. For local editing, the result is opposite, a significant difference for policy recommendation, but nothing significant for argumentation. The apparent reversal seen here between the second and third quartiles is not statistically significant. And finally, for interstitial pausing, both essay types show statistically significant differences, though not between the same quartile pairs, with more proficient students taking more time at locations associated with planning than less proficient students. The apparent reversal between the first and second quartiles is again not statistically significant. To summarize, we compared composition processes for more versus less proficient writers. We used 6 essays, 3 from each of 2 persuasive subgenres. We defined proficiency in terms of average performance across 2 essays in a subgenre, and we computed 4 individual process features and 4 composite process indicators from each essay response. We then averaged each dependent measure across 2 essay responses per student. We found that controlling for form, pair, and gender, more and less proficient writers differed significantly statistically on all individual features and on some of the process indicators. Compared to less proficient writers, more proficient writers spent a smaller proportion of their total essay time immediately before beginning to write. They had faster typing speed, they spent more total time composing, they started more words, and they entered text more fluently. That is, they not only typed faster, but apparently generated what to say faster. Finally, they paused more at locations associated with planning, which probably helped them generate what to say. These results held across both persuasive subgenres, though not always for the same quartile pairs. This study had several limitations. Among other things, we used unrepresentative examinee samples. We employed test-based writing in only 2 subgenres. Writing in the classroom may, of course, differ in fundamental ways. We excluded students submitting only 1 essay, which reduced sample size considerably, and we need more research to validate the process variable interpretations themselves and their relationships with writing quality. These relationships are not necessarily causal. Fluency, for example, frees up cognitive resources so that the writer can focus on higher order processes. But being fluent alone won't necessarily make one a better writer. What might be notable about this study? I think most notable is that we appear able to capture theory-based indicators from keystroke logs that describe how students compose an essay, that differentiate levels of writing proficiency, and that from other studies differentiate demographic groups, gender groups, and racial ethnic groups in particular. That doesn't suggest that writing process variables should be used in scoring consequential tests, which I suspect would just cause students to try to manipulate their writing processes. But it does suggest that we might be able to generate important information from summative writing assessment. First is the potential for policy information. For example, we might be able to identify which student groups need to improve computer-related skills, or identify whether teachers need additional training, for example, in instructing students how to edit more effectively. In addition, we might be able to generate formative information from summative writing assessment. We can tell if the student created an outline before beginning to write, if the student edited, where, when, what, and how much, if there was transcription difficulty in typing, spelling, or word finding, each of which produced different pause signatures, and if the student read what he or she wrote before submitting the final essay. We can even play back an essay as it was written, thereby giving the teacher a chance to analyze the student's process. Perhaps more importantly, it would give the student a chance to see and reflect upon how he or she composed, encouraging the development of self-regulatory writing behavior. In sum, I think that the examination of writing processes offers some good, new, and exciting possibilities for improving large-scale assessment. Thanks very much. Okay. Over to a discussant.
Over to Jim.
Okay, let me try to share my screen. See if I can be successful at doing this. Can you see my screen?
Yes.
Okay, all right. I'm going to try to do this and restrict myself to 10 minutes or Joan's going to cut me off at the knees. So first of all, I want to thank Kadria for putting this session together and for the authors of the papers. I think everybody will find the papers fascinating, just given the glimpse of what you heard today in the presentations. I want to my remarks, I'm going to cover 5 things. The first sort of front end rather quickly, spend the bulk of my time on the examples and my thoughts and reactions to them, and then a couple of closing remarks related about going beyond these cases and sort of why we need to do this, why it's necessary and not just nice to do this. So you've heard this in the presentations thus far, but I think that we realize that in many educational situations that we have focused on, we've been heavily concerned with just the final response. Did they make the right choice in a multiple choice? Did they write or otherwise sort of produce something that's in agreement with the scoring rubric? And for the majority of the time, our interpretation of what the performance means hinges on evidence of accuracy and correctness. And we either don't care about what they did to produce the response, or how they went about producing it, and or why they did it, or we choose to ignore what I call the what, the how, and the why as being less germane to the inferences we want to make. And it's also the case that until fairly recently, in many conventional testing contexts, it's been nearly impossible to collect response process data, but that has changed substantially in context of 2 things. First of all, is modern technology combined with contemporary theory about the situated nature of knowing, learning, and responding have really changed the evidence game. And I think Bob brought that to the foreground very clearly in his presentation. So we now have response process data that can come in many, many forms. It can take, you've seen examples here, timing of responses, keystroke and response patterns, even eye movements, verbalizations. Bob mentioned some physiological measures from the autonomic system. You can look at pupillary dilation. You can look at heart rate, breathing, all sorts of things. You can even look at butt position on chairs to see if people are paying attention. And the issue isn't that we can collect this stuff. The problem is, how do we make sense of it? And what value does it have? So I think that the opportunity is there, and the papers that we heard, the presentations, give us a glimpse as to the value proposition here. Part of the value proposition has to do with what I call validity arguments and evidence. And contemporary framing of this assessment validity involves an argument based upon evidence regarding the intended interpretive use of an assessment. So it's based on claims about what constructs are involved in the instrument and their meaning relative to evidence in support of those claims. What evidence do we have that what we say we're measuring is actually a reflection of the underlying construct, and what specifically is the nature of that construct? In many cases, the construct has been a sort of global construct about achievement or something of that sort, and our constructs have changed. Now, the joint testing standards have identified multiple possible sources of evidence, and they now include in that response process data as part of collecting evidence and building and supporting a validity argument. What happened here? So the claims that we might want to support, and I think this was again embedded in Bob's presentation and Roy's, have to do with things like construct representation, including things like complexity. They can have to do with score meaning, where we might be talking about fluency or accuracy or the level of sophistication of somebody's thinking and reasoning. As Kadria's presentation brought up, they can be involved in fairness, where we're looking for things to be unbiased, or issues of comparability, the claim that we're measuring the same thing in the same way. So I think there's a lot that response process data offer with respect to the whole issue of the validity argument and building that validity argument, and then finding evidence to support that in the form of relevant pieces of evidence that can come from response processes. So the examples we heard in this session, there were obviously 2 empirical programs of work using response time data and other data. The one that presented by Kadria on comparability and fairness of a math assessment, and Randy and his colleagues about an expository writing assessment. And then of course, Bob and Roy presented a conceptual argument, which is really based on the logic of assessment as a process of evidentiary reasoning, where here we're talking about the whole ball of wax from theory, construct representation, process data, and issues of evidence accumulation. So I'm going to spend just a little bit of time talking about each of them using some of the slides or the material from their presentations. So in Kadria's approach, obviously the concern was group comparisons and fairness research. And I think this is a very nice demonstration of how response process data can be used to enhance methodologies for comparing groups and fairness research, using the logic actually of differential item functioning, but applying that in a very nice way to response time data. And the issue that she posed was, what can we learn from these data on a mathematics assessment can inform group differences and fairness. And I think this is a very interesting one, because this is a mathematics assessment. So one of the questions is, what would we expect in terms of differences between ELLs and non-ELLs, given that this is a math assessment? It's not an assessment of English language proficiency, and yet the differences that she found. And what I really like about this paper was the adaptation of diff methodology to examine these differential response times for the comparison groups. And I think, you know, the data and the findings were really, I think, very interesting to me, and they really sort of get us to think about, well, what is diff telling us versus these differential response time data telling us in terms of comparability and fairness. The interesting patterns there in terms of the differences in the response times for the ELL at the different performance levels speaks to the question of, to what extent does efficiency, which shouldn't be in estimating mathematics, actually is contributing to differences in the meaning of the results of the assessment. We saw that ELL students needed to take more testing time. They actually might be substantially disadvantaged on a speeded test, or even not on a speeded test. One has to ask the question of, how much effort do they have to put out to essentially respond with respect to their mathematics proficiency relative to non-ELLs. And I think the pattern of results that Kadria showed about the differences in the second half of the test are really quite provocative. They really need to be looked at further, because they almost suggest that the students are getting exhausted or frustrated, or they're demonstrating fatigue. So you're raising fundamental questions about the comparability, fairness, and the interpretation of the meaning. So if a student scores the same, an ELL scores the same as a non-ELL, are they equally proficient, or in some ways may they actually be more proficient given the conditions under which they are being asked to demonstrate their mathematics proficiency? Let me turn to Randy's paper. Here we're asking about differences between more and less proficient writers. The work is really fascinating because it's drawn from assessments that were actually designed as part of the CBAL program. And obviously to do this work, they had to divide them up into quartiles. But what was so nice about this was comparing these writing process variables across these quartiles, and then looking at whether or not what we see on the summative assessment is evidence of patterns of performance consistent with essentially cognitive research. So we're not just looking for, the writing process is complicated and it unfolds over a long period of time. We're not just looking for differences willy-nilly, we're looking at them in a principled way, guided by theory about what do we know about the writing process. And the findings were I think, very consistent with the idea that the differences that they found between less and more proficient writers were consistent with what we tend to see in other studies of the writing process. So in some ways, these data provided, I think, some validation evidence that the assessment was actually getting at what you want it to be, which is a measure of the quality of somebody's writing and their writing proficiency with respect to argumentative prose. I think it's important, I think what Randy said was that there's no suggestion here that writing process variables could or should be used in scoring consequential tests. Rather, I think what Randy provided was some policy relevant information, things which might be useful from these data with respect to policy, but also with respect to practice. Here, the idea of using this information in a formative way with respect to in advising teachers and others about what students are doing so that in fact one can begin to think about further looking more closely at how the students are actually learning to write and respond, even whether it's in a formative or summative assessment contexts. I think one of the interesting issues too, and I've seen it in the chat, is to be careful about thinking about using these process measures as things for scoring. Because in fact, first of all, the writing process is extremely complex and there isn't one right way to do this in terms of how you distribute your time or your effort. So I now want to turn to Roy and Bob's presentation. And to do this, I'm just stolen some of their slides because I can't say it any better than some of their graphics. I think the point that they're trying to make here is a very large point about where does process data fit in a larger context of assessment in terms of the logic of assessment with respect to constructs, tasks, and argument and psychometrics. And we're now all familiar with the evidence-centered design model and representation, and the sort of framing of the elements of this, and now using that to think about where does process data come in. And I'll just cite two important cases. One, as Bob put it, was on the construct side. That is, the constructs we're interested in are different now in many cases than the constructs we traditionally used in psychometric work or in test theory. Those little thetas have different meanings now in terms of putting them in a socio-cognitive, socio-cultural theory. The other part is on the work product side. That is, we can think now about what we want students to do, but also the kinds of evidence that can be collected in the process of doing that, and actually design tasks or situations to accumulate that evidence. And of course, the critical thing with that is to essentially figure out what evidence matters. I particularly like the HIPPO task because it's a great illustration of how we need to think about what we're trying to get at. So in this case, you know, in many cases, if the student gives the right answer here, well, we don't care, they got it right. But if you're a developmental psychologist, if you're a cognitive psychologist, if you're a teacher worried about where students is in a progression of their understanding of mathematics, it matters a lot. And so if a student does it one way versus another, it has very different interpretive meaning and potential consequences with respect to whether a student, what do we mean by a student's proficiency, or where are they on some learning progression? So I really like this idea of a dialectic among theory, activity, design, data exploration, and evidence evaluation. So what they're saying is, let's think about this in a more holistic way in terms of all the elements of what we're trying to do in connecting constructs and evidence and how we factor that in. And of course, we can't have a presentation without a quote from Messick. But this is a very provocative statement, that these are not just measurement niceties, these are social values. And then, as they point out, we have to think about this in terms of extended arguments, not just more data that makes our lives more complicated. So I'll just try to quickly end with two slides. I think, you know, these two empirical cases are really the tip of the iceberg for response process data. They're using aggregate data, they've decomposed it. There's many other forms of data possible, and many possible combinations of evidence. But go there cautiously. But the importance of this is in terms of these kinds of data don't just come in at the end. They are critical to designing assessments, and they contribute to key parts of the evidence in a validity argument. They also, as Bob pointed out so nicely, permit us to broaden the constructs we can assess in line with contemporary theory and can give us more meaningful information for interpretive use and application, particularly at levels close to the classroom. But the caution is these are not simple data. They're often messy. You can get, you know, you can have an ocean of data that you can drown in. And the important thing is they need to be theory driven. And whether or not they should contribute to scores or not, I think that's a big maybe. I think once we start indicating to students that we're also tracking how they get their answers, we may be fundamentally changing what they do and then the nature of what we're measuring. Thanks.
Okay, my turn, I think. So, in the interest of allowing time for others to, in the Zoom universe, to share their thoughts, I'm not going to try and go through my slides. I'm just going to make one point about each of the presentations. I was really thrilled and inspired by Roy and Bob's piece. They're calling on us to, as a field, to move from a relatively narrow focus on analyzing data and models to a higher level, more comprehensive view of the whole process of test development, test design, test use, grounded in models of learning. I think that's an incredibly important point. They further situate this greater psychometrics work in current learning theory and the social and personal contexts in which our work occurs. They argue for psychometrics as a team sport and elucidate the importance of the interplay between theory and analysis, between data and evidence, and relevant evidence in particular, and the role that that process can play in both strengthening our understanding of human behavior and our measures of it. Although many of us in this session probably may have bought into this view, I wonder about the larger field as a whole. I think this is an incredibly important message and really commend the paper to you. Moving to Kadria. Kadria's work, I think, shows the incredible value of a relatively narrow psychometric view. She uses very careful methods and very good graphing and analysis of data to demonstrate how response process data can be used to inform our study of the fairness of our measures and finds differences from more typical responses. Her approach is bottom up, and I think it's fair to say the hypotheses come after and not before. And so now there's a rich research agenda yet to be explored in her exploration of process data. And I would just encourage her to feed into it, models of learning in mathematics, and what we know about that, I think, could inform what we know. In the move to Randy, I think we're moving towards greater psychometrics. You see in the work this incredible interplay between cognitive theory, prior research on writing, and the work he and his team are doing to make sense of log data. It's a very carefully designed set of studies and a very wide agenda that has important implications for the field, but yet, even as careful as this process has been, lots of conjectures remain. As I think about this work, I have some wonders, some of which were somewhat covered, others not. I wondered about the intended use of response data. If, as all the presenters lay out, one of the purposes of analyzing response data is to better understand and provide alternative measures of student learning, I wondered how and by whom they anticipated the measures would be used. Randy, of course, deals with this issue at the end of his presentation. I wondered how you might decide on the value add of these data and when they were worth it and when they weren't. When might it be appropriate to include users in the design process? Granted, given Randy's example of the CBAL work, actual practical use, we may be at a long distance from that. But what should be our priorities for the research agenda for these kinds of data as a whole? One important thing on my list, and something that Jim talked about, are issues of validity. If response process data are indeed considered measures and we draw inferences from scores, how will we assess their validity? At what point does it make sense to do so? Like Jim, I'd argue we need to follow the standards for educational and psychological testing and evaluating validity. We need to use an argument-based approach using multiple sources of evidence. So far, I think it's fair to say that the approach to validation has been less formal. So that was a very fast talk. To leave it open for you, my colleagues in the Zoomosphere, to raise your questions and comments. And I think if you have additional questions, please use the chat box, because I'm thrilled that there are so many of you joining us, but it's be hard to call on you. So while those of you who have questions might be adding them to the chat box, let me ask a question that was posed to all presenters, if I can find it. And the question is, in the context of high stakes testing, what's your opinion about how to communicate to students that process data may be used directly or indirectly to calculate a score? Anyone like to volunteer to take on that question?
Bob did in writing, so he may want to respond.
Sure. There are the cases, like some of the ones that Kadria talked about, where process data like timing was captured but not used in any kind of score. That's fine. If it seems to me, though, that if you're going to use it as part of a score, when you're using a test as a contest, bring in the entire set of considerations that have to do with running a fair contest. And that includes making as transparent as you can to everybody in the contest how their performance will be evaluated. And so you don't necessarily have to help them learn how to calculate maximum likelihood estimates. But what that does say is whatever uses that you have ought to be understandable enough to a participant there that they have the information they need to rationally figure out how to perform in ways that best help their score. And as one of the people in the writing comments suggested with respect to coaching schools, you can be sure that they will be among the first to find out what optimal strategies will be and how to use that information, because both they and the candidates have a good reason to know that. I would also say that if you're going to be using that timing data, or how many erasures you have, or drawing a straight line across the response pattern, you ought to have a construct relevant reason for doing that. Because if you don't, if scores depend on something that is construct irrelevant, you will get to argue your case in court about that, and you better have something to say.
I think
Could I add to that? Oh, I quickly adding to what Bob said. Of course, we need to inform students about what they are scored on for sure, but also avoid including constructively relevant observations. And one example that came to my mind is in writing assessment. For example, in paper-based assessments, students did their handwritten writing and constructed essays that the intention is never to include how well they write their scripture. So it's, or script writing. So it's similar to try to take other observations from process data and included in scores. I think it's really important for us to make sure that anything that gets scores have rationales with respect to supporting the construct measurement, as well as informing the participants and students about what they are being measured on, what they're being scored for.
Said another way, whether or not to include process data in computing a score depends critically on the nature of problem solving in the domain in question. In medical problem solving, for example, process is critical. How one arrives at a diagnosis is as central as the diagnosis. The diagnosis may have little meaning if it was arrived at in a flawed way. The patient could be put in jeopardy if the process of diagnosis and process of treatment was flawed. So in that context, it's central, process data. In the context of writing assessment, what counts is the outcome, not the process. However, when a student is producing a flawed piece of writing, examination of the process may help and identify some of the contributors to that flawed piece of writing, or might imply ways in which writing could be improved.
Well, I'm looking at the clock and seeing that it's 10:29. So I think, unfortunately, Randy's going to have the last word, and it was a very good one. Unless, Jim, you have something you wanted to say. I didn't give you a chance to comment on that question.
Well, I can with colleagues about using sort of certain kinds of process data for purposes of scoring. It can be very problematic, particularly since in many complex situations, there are different strategies or ways to get to the right answer. In some cases, we want to know the strategy because some are more efficient and less efficient than others. But I sort of agree that if you start trying to coach people on strategies, you're actually sort of doing something that people did long ago, which was a big mistake. When they first started using eye movements to study reading, they found that the eye movement patterns of good readers were different than the eye movement patterns of poor readers. So what did they try to do? They tried to coach the eye movements. And the eye movements had nothing to do with the strategy. They had to do with the underlying process of where you were spending your time and allocating and the differences between good and poor readers. So be very cautious about this, because while it can support validity arguments and evidence about whether the assessments are accomplishing what we want, or that little hip example give us information that might be instructionally quite useful with respect to learning progression for other purposes. Be very cautious about the whole issue of sort of monitoring. We're monitoring you all the time, 24/7. And I have questions with the idea of stealth assessments too, for similar reasons. So, but that's a longer conversation.
Okay, so that will be our final word. We move forward with lots of caution and lots of possibilities. So I want to thank Kadria for putting this session together. I want to thank the presenters and Jim for just excellent work. And I want to thank all of you who joined us in this Zoom meeting for being here with us. And good luck to everyone. Stay safe, stay sane, stay healthy until we meet again, either through this venue or otherwise. Take care.
You too. Thank
Thanks,
you all.
everyone.
Bye.
Bye-bye.
Bye-bye.